In this video, we'll consider conservation of momentum problems where both objects are stationary before or after collision. Let's read these blue words to get started. When objects move in opposite directions, we need to consider one, to have positive momentum, and one to have negative momentum. Now, generally speaking, in this course, we avoid assigning signs to numbers, for instance, velocity or force. Rather, say for force, say I wanted a force of 20 newtons in that direction to my right, I would call that 20 newtons east. We use the directions rather than positive and negative signs. But since in momentum we have to add these together sometimes to get totals, when momentums are in opposite directions, we need to have signs. And generally speaking, a motion to the east is positive, a motion to the west is negative. So let's just look at these examples. This here is motion to the east. We're going to consider it positive. Of course, this mass times velocity, 5 times 7, we get 35, and I'll call that a positive 35. Here we have one in the opposite direction. It makes us need signs. This one has to be negative. So it's going to be 4 times 6 is 24, and that one's going west, isn't it? So we'll call that negative. Of course, that results in total momentum of positive 35 minus 24. Yet the total momentum is now 11 kilogram meters per second. We do this because momentums in opposite directions cancel each other out, either completely or partially. This one here partially. So we'll have to consider positive and negative momentums later in this video. Alright, so here's the situation. Let's say that after collision, neither ball moves. These are both stationary. Well, it's not rocket science to say this one has no momentum, nor does that one. Our total momentum then is 0. What's total momentum before then? Well, with conservation, the total must be the same, so the total before is also 0. Now let me read this. If before collision there was movement here, one or both were moving, how could momentum before collision equal 0? It's got to, right? Well, I think you realize from the first thing we talked about that these objects here must move in different opposite directions, don't they? Here's your video code. Yep. Yes, the only way for these two, if they're moving, to add up together to have 0 total momentum is to have one going in one direction, one going in the other. This one's going left or west. So if it's 9 kilogram meters per second, we'll call it negative 9. So what must this one be? Sure, to add to 0, it must be positive 9. So these do add to 0, and there we have our conservation of energy situation. These guys apparently hit together, and both of them stopped afterward, which can happen, right? Good. So there are two ways for a pair of objects to have total momentum of 0. The easier way, and the more obvious way, is that neither are moving, sitting still, both 0, total is 0. The other way is if they're moving in opposite directions with the same momentum. Say a positive 9 and a negative 9. Those will add to 0 as well. Now forget, did I mention your code? Your code is yup. Bye.